Right, so today we're going to be starting a new topic. Having just finished off and had a good look through probability, we're going to be starting off looking at algebra as a class together. Today we will be just having a bit of an introduction to algebra and looking at writing expressions, how we can do that. Okay, that's what the focus of today is going to be. So what's algebra all about? Have a think about that maybe yourselves. What do you understand algebra to be? When someone says algebra to you, what do you think? All right. Do you think about using letters to stand for numbers? Do you think about formulas? Do you think about equations? Do you think about expressions? Do you think about terms even? All these sorts of things are connected in with algebra. They're all parts of algebra, all things that will either be doing in algebra or that we call things in algebra. So they're all to do with algebra. And algebra might look something like that. We've got letters and numbers all mixed in together. We've got formulas. Yeah, we've got numbers, letters, things happening with the numbers and letters. The letters standing for numbers. And we get expressions and equations, okay? Things like that, where we see lots of X's and Y's usually. X's and Y's are letters we use a lot in algebra, but we might use any letters, really. M's occurring here as well. Okay, so that's what algebra is all about, using letters to stand for numbers, and we get involved with formulas, equations, expressions, and terms. So how is algebra useful to us, though? We spend a lot of time studying it in maths at school. How is it useful to us? How might it be useful to us? Well, first thing is to know it's often a faster and better or more efficient method at working things out. All right. When we start off learning maths, we can count to 12, count to 24 even. But multiplying 2 by 12 is a lot quicker than just counting to 24 or adding 2 12 times. And just like when we learn about multiplication, it makes things quicker for us than just doing adding. Learning about algebra makes things quicker for us than just doing ordinary number calculations. It helps us to develop a logical thinking method, okay? So it helps us to work on logical thinking, doing things in the right steps, following a set of rules in order. It helps us to become logical in the way that we think about things, and that can go way outside of maths and sciences into social sciences, into history, into geography, into lots of other areas. It helps you to become logical in the way that you think. It can be helpful in the real world. You probably asked a lot of people in the real world, do you use algebra much day to day? They'd probably say no, not at home. But in their everyday lives, they're possibly not going to be doing that. But it can be useful. It can help around financial decision making, insurance, planning trips, lots of things around that. It can be helpful. I'm not saying you would use it every day at home, but it can be useful. But it certainly does help with other subjects and open some of these other subjects up. So if you want to study science further and medicine further, statistics, you want to become an engineer, get involved in architecture, study calculus, all these things are going to be opened up a little by you having algebra. Algebra is going to be useful. It's going to feature in all of those things. It helps us to prove things. Okay, algebra helps us to prove things. Now, what we mean by proof is to show that something must always be true no matter what. Now, I might be able to convince you with a few words and a few examples that something is true. Like if I add any two odd numbers together, I get an even number. You might think, yeah, that makes sense. I can see that. I take the number 5 and I take the number 7, add them together. Yeah, that's even. And you might convince yourself that that's true. But how could you convince someone that that is always true no matter what numbers that they chose? How could you convince them? Well, algebra helps us to prove things like that. And finally, it is actually quite beautiful. It is a set of rules that can lead to some quite beautiful results. So just popping up here on the screen, this is a Mandelbrot set. So some of you might have heard of Mandelbrot sets before, you might not have done. But that picture is a result of working with some algebra on an equation. Okay, maths, and in particular algebra, has led to that picture. All right, so it can be quite beautiful. So before we start, just a few things to remind ourselves about algebra and make sure we're happy with. First of all, really nicely, all the rules that we've learned about adding, subtracting, multiplying and dividing that relate to numbers also apply absolutely to algebra as well. So all our ideas about order of operations, BIDMAS, that kind of thing, they all work. Everything that applies to numbers about multiplication, division, addition and subtraction applies in algebra as well. And once you learn some of the tricks, which they're really skills, it can become a fun challenge to work out how to use your skills in solving some puzzles. All right, so here's an example of a puzzle that algebra really helps us with. And it reads quite confusing. You try and read that, it can look like there's a lot going on there. So the sum of three numbers is 231. If we add all the numbers together, we get 231. Tells us the third number is larger than the second number by the same amount that the second number is larger than the first number, and then tells us the first number is 27, and asks us to find the other two numbers. Okay, that is absolutely the kind of puzzle, the kind of question that algebra will really help you solve very quickly and efficiently. By the way, I'm not expecting you to do that right now. We'll build up to stuff like that. Absolutely, we will. Okay, today's just the start lesson. If you wanted to have a think about that, then by all means do. You might even be thinking, I could do that without algebra, and you might think of ways to do that. All good. Algebra is a really efficient way of dealing with that, though. We'll come to that a little later. Okay, so our lesson really today is all about writing expressions. So what are expressions? Well, maybe if we do an example, we'll see what sorts of things we mean are expressions. But expressions are really just something that has got letters in it, where we're using algebra in some way. Okay, so I'm going to start by saying, if we let the letter X stand for my age now, so how old I am now, can we write an expression? So the expression will have the letter X in it, expression using X for my age, first of all, next year. So X is my age this year. Can we use algebra to say what my age would be next year? Well, what do we do to our age this year to get our age next year? We just add 1, don't we? So my age this year was X. My age next year must be 1 more than that, X plus 1. Okay, that is an expression. Okay, it is a statement just with letters and numbers in it. It's called an expression. So the expression for my age next year is X plus 1, because my age this year is X. I add 1 onto it to get my age next year. All right, what would my age be in 2 years' time then? So not next year, but the year after. So again, we think, if I know my age today, how do I work out my age in 2 years' time? What do I have to do? Well, I just have to add 2, don't I? So if I know my age today, which is X, if I add 2 to that, I'm going to get my age in 2 years' time. That's the expression. In 12 years' time, what would my age be? Again, I know my age today is X. To get my age in 12 years' time, I would add 12 to it. Okay? Not tricky, really, is it? Just thinking about what we do and just bringing that letter in. And the letter stands for my age now. What would my age be a year ago? So I know my age now. What do I have to do to work out my age a year ago? I subtract 1 from it, don't I? So that's my first expression now that we've written where we've got to subtract in it. Fine, we can do that as well. My age this year, subtract 1, give my age a year ago. My age 5 years ago, again, same sort of idea. I know my age today. To work out what my age was 5 years ago, I just subtract 5 from it. So my age 5 years ago is X minus 5. Just going to give you the chance to have a think about this for yourselves. There are a couple of questions there at the bottom of the screen. So in a minute, just pause the video and have a go at these ones, and then we'll come back and have a look. So can you write expressions for what my age would be in 17 years' time? And can you write an expression for my age 20 years ago? Okay, in 17 years' time and 20 years ago, can you write the expression? Pause the video now and resume it once you're ready. Well, to work out my age in 17 years' time, we add 17 to what my age is today. So my age will be x plus 17. To work out my age 20 years ago, I subtract 20 from my age today, and I get my age 20 years ago. If you got those two, well done. All right, we're just thinking about what's happening. We're looking 17 years from now, and we're looking 20 years ago from now. So they're expressions. Those sorts of things are expressions. Let's take another example. So suppose we've got a class in school, and we're saying we're going to let the letter N stand for how many students that there are in that class. So if 2 members of the class leave, we're being asked to say how many students are in the class now. Write an expression using N. Well, if 2 members leave, from our original N, we've taken 2 away. Okay, if 2 members were to leave, that's what we'd be left with. How many students are in the year group if there are 4 times as many in the year? So there are 4 times as many students in the year as there are in the class. Well, this is one of the things to look at with algebra. We'd take the number of students that are in our class and we'd times by 4, wouldn't we? To work out 4 times as many, we'd just write that down. But in algebra, we don't usually write times signs between letters and numbers. And we have a rule that says we will always write the number first and then the letter second. Whenever we see that, it means times. Okay? 4n means 4 times n or n times 4. It's the same thing. All right, so in algebra, we don't do that. But we know if there were n students in the class and there were 4 times as many in the year, there'd be n times 4. We write that as 4n. How many girls are in the class if half the class are girls? Well, how do we work out that? How do we work out half the class are girls? Well, wouldn't we take the number of students in the class and divide it by 2? Wouldn't that work for us? Yeah? If we know the total number of students in the class, half of them are girls, divide it by 2. That's what we need to do. Number of students divided by 2. And again, in algebra, we tend not to write divide signs. All right, we write them like they're fractions. Remember, a fraction is a divide. All right, this thing, n over 2, you would write it like that. You could also, if you wanted, write it as a half n. They mean exactly the same thing. Okay, it's up to you which one of those you prefer writing it as. Half of n or n over 2. Because remember, the fraction is really a divide. Okay? So if we had n students in the class and then m more students join, so this is another letter, we're using another letter for the number of students that joined, but I had n to start with and m more come in, so I'm going to add those m on. All right? First expression there where we've got 2 letters involved. The original number of students plus the number of students that have joined. Okay? And the number of girls in the class if 3 girls then left. Well, we know from part C here how many girls are in the class. There are n over 2 or half n. We know that. So let me do my half n. Is how many I did have. They were the girls. But 3 have left. So I have to take 3 away from that. Okay? All right, so we're starting to get a bit more involved here in this example. We're looking at multiplying, and we need to remember that when we're multiplying, we just write the number in front of the letter, and we start dividing, and when we're dividing, we can either write it as a divide as a fraction, or we can put the fraction in front of the letter. Either of those are okay. Right, can you write expression for the number of students in the school if there are 15 times as many as there were in the class to start with? We know how many there were in the class to start with. Okay, we've got that right at the top of the screen. That's how many are in the class to start with. There are 15 times as many students in the whole school. Can we work out an expression for that? So pause the video, have a go at that.